The equation can also be y is equal to 2a sine kx cos omega t. Now, what is the difference? What is the difference? When we went through this, which one did we get yesterday? Is it the first one or the second equation? Which one did we derive yesterday? Class, which of these two equations did we derive yesterday? Is it the first one or second one?
The first one and the second one too.
Okay, so we have the two stationary wave equation being 2a cos kx sine omega t or 2a sine kx cos omega t. Now, the question is that what is the difference? The difference is that if you have a stationary wave formed as a result of having two boundaries or at a closed boundary, you see, if the wave is starting from left to right, there's a boundary at this end or barrier. So we call this as a closed boundary. If you have a closed boundary or closed ends, the wave is like this. And when it hits the barrier, it reflects to form a stationary wave, which looks ugrily, as I've drawn, which looks ugrily as this. When it is like this, its equation will be equal to this. So if you have for a closed boundary or barrier, okay, the equation of the stationary wave becomes y is equal to 2a sine kx cos omega t. So this is for a closed boundary. Don't forget, for a closed boundary, and nodes are formed at both ends. So a sine wave which looks like this. Okay, if we have a sine, this is a sine wave. And if a sine wave starts from 0 and ends at 0. So if we have a stationary wave formed from closed boundaries, then there are nodes at both ends, nodes. And so the equation will be equal to, the amplitude is 0. And if the amplitude is 0, you can only get that when the amplitude function is equal to sine. Okay, so this equation is for closed boundaries or when there are fixed points. Now, if the stationary wave is formed such that it is like this, okay, you see over here, the difference between these two is that here it begins with an node. Here, the wave begins with an antinode. Okay. So in antinode, when it starts from antinodes, ends in an antinode, it is when there is an open end, reflection from an open end, meaning in this kind of wave, the end is open. So it starts from an antinode. If you have a stationary wave formed like this, the equation becomes y is equal to 2a cos kx sine omega t. Because if you have a wave like this, starting from an amplitude like this, This is a cosine graph. Okay, so this is a cosine graph, whereas this is a sine graph. And so if the wave is such that, okay, it starts from an open end, then antinode begins at the open end and at the closed end. And so we must have an equation which is expressed in terms of cosine. So we can have these two different stationary wave equations, either this one or this one. So take notes. Please, any question before we continue? Amma, any question? Charlotte, Lizzie?
No, please.
Amma,
Yes, sir.
do you have any question?
No, please.
Or we are going to solve questions with. So the equation can be where the amplitude is 2a sine kx cos omega t, or 2a cos kx sine omega t. If the amplitude function is a sine, then it means it's a closed reflection from closed boundary or barrier. If the amplitude function is cosine, then open barrier. So take note of the difference. Then we also discuss points where nodes and antinodes will be formed. A quick revision so we can apply this in solving questions. Points where nodes and antinodes will be formed. If we look at this function, the amplitude of the stationary wave A subscript SW. Here, I mean amplitude of the stationary wave is equal to 2A sine kx. A stationary wave can have an amplitude of plus or minus 2A on condition where sine kx is equal to plus or minus 1. So when amplitude is equal to plus or minus 2A, then the trig function sine kx. So for antinodes, sine kx must be equal to plus or minus 1. And so we need to look at the angles which will give us possible angles which will give us plus or minus 1. And so yesterday we realized that then kx will be equal to either 90, but please, quickly, your angles in degree must be changed to radian because this is simple harmonic. And in simple harmonic motion, angular measurement is in radians. So this is the reason why we change angle from degree to radian. So when kx or theta is 90, we'll have 1. So pi on 2. So this is one possible angle where the amplitude will be equal to 2a. The other angles, we saw that when theta or kx is equal to 270, and 270 is equal to 3 pi on 2. Now we realize that the angles will be in odd terms. So 5 pi on 2, and the nth angle will be n 2n minus 1 over 2 pi. So this will be the nth angle. So if kx is equal to 2n minus 1 all on 2 pi, then we realize that x, we substitute k for this 2 pi over lambda. So that 2 pi over lambda x will be equal to 2n minus 1 on 2 pi. We find the value of x, and x is equal to 2n minus 1 over 4 lambda. So here we are determining points where antinode will be formed in terms of wavelength. Meaning, if you know the wavelength, you can easily calculate for x. So for n is equal to 1, x will be equal to quarter lambda. Okay. For x, n being equal to 2, this will be 3/4 lambda. For n equal to 3, 5/4 lambda, on and on and on. So it means these are points where antinodes will be formed. Let's see if it follows what we have done. Okay, let's see if it follows from the diagram. Look at our wave is this. Reflection, once it's a sign, then this is when there is a closed boundary. Once the trig function is assigned, this is for a closed boundary. So it is this way. Let's see points where antinodes will be formed. An antinode will be formed here, 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 here. Let's even pick just 3. This is from node to antinode, and the distance will be, in terms of wavelength, this is quarter lambda. So it matches the first value we had. The first value we had is this. What is the second antinode? The second antinode will be here. From antinode to antinode, what is the distance? What is the wavelength from antinode to antinode? What is the distance from A to A?
Half lambda.
Half lambda. So if we want to measure x from here, it will be this whole distance. Okay. So if this is half lambda plus this is quarter. LCM 4. This is 2. So 2 lambda plus lambda. 3 lambda over 4. It matches what we have as the second position of antinode. Then another point where an antinode will be formed is here. What is this distance from the end? Meaning from here. Meaning from here up to this point. From here to here, it is equal to 3/4 lambda. So from this point to this point, 3/4 lambda plus another plus half lambda. Okay, so 3/4 lambda plus half lambda, LCM 4. This is 1, so 3 lambda plus 2. 2 lambda is equal to 5 lambda on 4. Exactly so. So whatever we had matches whatever position of antinode on the stationary wave. Okay. So when you know lambda, you can easily determine x, the distance from the first point where antinodes will be formed, on and on and on. What about nodes? For formation of nodes, we saw that for formation of nodes, we saw that this must be equal to 0, and this will be equal to 0 when sine kx is equal to 0. So what are the possible angles where the whole the whole of this will go to 0. So we got kx to be equal to 0 if theta is 0, yes. Then when theta is equal to 180 pi, when theta is equal to 362 pi, okay, on and on and on. So generally, this is equal to n pi. So kx being equal to n pi, 2 pi over lambda x is equal to n pi. Therefore, pi x will be equal to half n over 2 lambda. So for n is equal to 0, we'll have x being equal to 0, and it will match here. This is the point where x is 0, and a node will be formed there. For n is equal to 1, x will be equal to half lambda. This is another point where a node will be formed, and the distance is half lambda. N is equal to 3. Oh, sorry, n is equal to 2. X will be equal to lambda. For n is equal to 2, x will be equal to lambda. So this is another node, and this is a whole wavelength, so lambda. Okay, so this our values also matches whatever we have on the stationary wave graph. Please, is that okay? Any question? So solving the problem actually depends on whatever question is given to you. Let's apply this in solving a problem. First question, and I'm reading. All right, so where is the question? Give me a minute or two to get a question. All right. For the stationary wave,
No, please don't clean it.
but you didn't say it. Charlotte, I'm recording.
Okay.
Or you know what the video, Charlotte.
Please, I'll watch.
But next time you want to write, you draw my attention to it. So for the stationary wave, y is equal to, the stationary wave given to you is y is equal to 4 sine pi x on 15 cos 96 pi t. Determine the distance between a node and the next antinode. Determine the distance between a node and the next antinode. That's the question. Five minutes. Let me see what, just think around You may be right, you may be wrong. Just give it a thought. Think through it. Let's see what you can do. If you are asked to solve this, you are to determine the distance between a node and the next antinode. Okay, so give it a try. Let's see what you can do for just 5 minutes. Then I come in. All right. Class, are you there?
Yes, please.
Let me see. Check on attendance. Whoever gets it right will go to Dubai after Ebola. Determine the distance between a node and the next antinode. But the question is that, is this a stationary wave? Is that a stationary wave? Class, looking at the equation given to you, is that a stationary wave? Hey, nobody is talking. Oh. Lizzie, Amma, and Co. Looking at the equation given, is that a stationary wave?
Yes, please.
Why do you think so, Adwa? Why do you think this is a stationary wave, equation of a stationary wave? Adwa, why?
I think it was formed from two different waves traveling the opposite.
Okay, so if you compare this two, y is equal to 2a sine kx cos omega t, you conclude that this is a stationary wave. Okay, so it is also done as a result of that comparison. Okay, so clearly it tells you that the amplitude of the stationary wave is equal to 4. So if it's a stationary wave, then there will be antinodes and nodes. Determine the point where a node and an antinode will be formed and find the distance between a node and the next antinode. That is all. Stephanie. Oh, Stephanie is not here.
Please, I'm here.
Okay. It isn't scary at all. Just give it a try. Let's see what you can do.
Yeah.
Hello, Amma.
Please, can you write the equation you wrote earlier? I want to see some.
So from the equation, it is clear that this is reflection from closed boundaries. So the station wave will look like this. It will look like this. Reflection from closed boundaries.
Okay. Mr. Adria, you've managed to confuse.
Pardon?
I'm confused.
Oh, but I said this, I explained this to you earlier. I explained when
So when
it
it is closed,
Mhm.
it is closed, the engine will be sine WT.
Sin,
Isn't it so?
sin kx cos omega t. Sin kx cos omega t when it is closed. When it is open, it will be cos kx sine omega t. So this is for closed boundary. And then 2a cos kx sine omega t is for open boundary. You understand this open boundary thing today? We'll be doing application of stationary waves. So
Okay.
when you compare this to this, it means that this equation given to you is when we have reflection at closed boundary. So the wave will look like this. The stationary wave will look like this.
Okay, sir. Thank you.
You have 2 minutes of thinking through. 2 minutes of thinking. So we are to determine the distance between a node and the next antinode. Okay. So if you see, when we went through the formula, we saw that for closed boundary, one will be odd and the one will also be even. Okay. So even if I don't remember which one is odd, which one is even, I can still derive it here. And so I'm going to solve it by looking at if I have no idea which one is odd, which one is even. So for antinode, the amplitude of the stationary wave A subscript SW, which is equal to 4 sine pi on 15x. For antinode, this must be equal to plus or minus 1. Class, are you okay at this particular step? Are you okay with this? Hello, are we?
Yes, please.
So
Yes,
for
please.
antinode to be formed, that the amplitude, which is this, must be equal to plus or minus 1. If this must be this, then it means that sine pi on 15 x, which must be equal to plus or minus 1. Because when this is plus or minus 1, we'll get a amplitude of either 4 or minus 4. Therefore, pi on 15 x must be equal to possible angles. So this is similar to finding the sine inverse of this. You see, if you have sine theta is equal to 1, theta is equal to sine inverse of 1. And that is, theta will be 90. But over here, you see, different angles will give us plus or minus 1. So we try to look for the different angles. Okay, because we don't have just a value plus 1 or minus 1. It's plus or minus 1. So this is also similar to determining this angle. Pi on 15 is equal to sine inverse of plus or minus 1. But different angles will give you this. So we have 90 will do pi on 2. Then I think 270 would also do, which is 3 pi on 2. So this is odd. The next will be 5 pi on 2. So generally, the angles will be n, 2n minus 1 pi on 2, or 2n minus 1, all divided by 2 pi. So we've had the different angles. Okay. So pi on 15 x is equal to the nth formula, which is 2n minus 1 all on 2 times pi. Then we find x. X will be equal to, pi will cancel out. So we'll have 15 times 2n, in fact, 2n minus 1 over 2. And what is 15? 15 is 7.5. So 7.5 2n minus 1. So these are the possible expression for determining n. So when n is 1, x will be equal to 7.5. When n is 2, x will be equal to, this is 3 times 7.5. And what is 3 times 7.5? I think 22.5. Is that correct?
Yes, please.
Okay. So it means that these are the different positions where nodes, antinodes can be located. You can determine when the third point where a node will be formed, n is equal to 3, and x will be equal to 7.5 times 5. Is that okay? So we have identified points where antinodes will be formed. The question is about the distance between a node and the next antinode. So we need to determine points where nodes would also be formed. Okay. Class, are you okay up to this stage? All right. So let's identify points where nodes would be formed. Then we find the distance between the node and then the next node, the next antinode.
Lydia,
Hello, Charlotte.
please, so how would you know that? Okay, like 4 sine pi on 15x, if you are supposed to use the one that's equal to 0 or the one that's equal to plus or minus 1.
You see, an antinode, if you have a stationary wave like this, this is antinode. An antinode represents the maximum displacement. Okay, so for this look at the stationary wave. This is its amplitude. So the amplitude of the stationary wave is not just a value, but it's a trig function for sine pi x on 15. Okay. From what we have, it is clear that the amplitude will be equal to 4. The amplitude of the stationary wave will be equal to 4. But it will be equal to 4 at different angles. Meaning, if this part, you see, this is 4 times sine pi x on 15. If this part is equal to either plus or minus 1, we'll get our value of 4, which is the amplitude. And antinodes are formed at the amplitude. So when you determine an amplitude, you have determined an antinode. Charlotte, are you okay? When you determine an amplitude, you have also located an antinode. So how can we determine the amplitude or antinode? We can go through that if this part is equal to plus or minus 4, because if this part is plus or minus 4, we'll have 4 times either 1 or 4 times -1, and we'll have either this value as measured from here or this value as measured from here, 4 or -4. So Charlotte, this is the reason why we are equating sine pi x over 15 to plus or minus 1, so that we can get different angles where antinodes will be formed. Charlotte, are you okay?
Yes, please.
And for nodes, as for nodes, they are point of zero displacement. Point of zero, it's just on the equilibrium position. So if the trig part is equal to 0, we have identified a node. That is why in identifying nodes, we equate sine pi x over 15 to 0. Okay, but we have different points. This point, okay, so this point clearly means that x must be 0. This point will mean that x must be equal to 7.5 per our question. So when x is equal to 7.5, we'll have this. And when x is equal to 22.5, we'll locate another node. And when x is equal to the other, are you okay?
Yes, please.
Hey, what we were calculating was for antinode. Sorry, we are here to look for. Amma, what's the question?
Please, why is amplitude 4 and not 2?
Pardon?
We said amplitude is 4, but according to the equation, it is 2a. So why is amplitude not?
The 2a is just a general formula. It is similar to giving you a progressive wave equation, a sine omega t minus kx. And I'm saying here the amplitude is a. So this is for the general formula for progressive wave equation. But for stationary wave, we are saying that each general formula is 2a sine kx cos omega t. So this is a general relation, but I've given you a real question. A real question. That is this. So this 2a can be equated to 4. Okay, this 2a here can be equated to 4, so that a is equal to 2. If a is equal to 2, it means that the amplitude of the two progressive waves that superimpose is equal to 2. Amma, that is what it means. Are you okay?
So say if the answer was amplitude, which one should we choose?
Come again.
So if the answer which one is the amplitude, which one should we choose?
The question will be specific. What is the amplitude of the stationary wave? If it's about what is the amplitude of the progressive wave, the two progressive waves? Are you okay?
Okay.
So the 4
Yes.
refers to the amplitude of the stationary wave, whereas but this will be plus or minus 4. Don't worry, don't forget. And then the amplitude of the two progressive waves that interfered will be plus or minus 2.
Okay.
All right, so we have identified antinodes. Let's find nodes. So please ask questions if you are not clear with something. So for Lizzie, oh, Akoda. For node, the amplitude function ASW, amplitude of the stationary wave, which is 4 sine pi x on 15 must be equal to 0. Charlotte, for node, are you okay?
Yes, please.
Now, if this is it, you see, when you divide through by 4, it's still the value is the same. So for this to be obtained, then what are the different angles? Sine pi x on 15 must be equal to 0. So it means that pi x on 15 must be equal to the different angles which will give us 0, or where sine will be 0. And what are the angles? We have 0. 0 will do, because sine 0 is 0. Then 180, which is pi. Sine 180 would give us 0. Then sine 362 pi. So we realize that this will be n, both even and odd. So the n formula will be n pi. Therefore, we have pi on 15x equal to n pi. Pi will cancel out, so that we have x is equal to 15n, meaning when n is equal to 0, x is 0. When n is equal to 1, x is 15. When n is equal to 2, x is 30, on and on and on. Okay, so these are the different positions for nodes. Different position for nodes. This is the first node, second, third. These are nodes. Antinodes, we got the first one at, for antinodes, we got the first one at x is equal to 75, 7.5. X is equal to, and then x is equal to 22.5. And then what is the next node? What's the next antinode position? When n is equal to 3, 5 times 7.5. What is 5 times 7.5?
37.5.
Okay, so 37.5. Now look at something. The question demands that determine the distance between a node and the next antinode. Okay. The first node is 0. The first node is 0. The first antinode, 7.5. So if the first node is 0, the first antinode is located at 7.5. What is the distance between a node and an antinode? plus if the first node is 0 and then the next node is 7.5. What is the distance between a node and an antinode?
7.5.
Let's locate the second node and antinode. The second node is located at 15. X is 15. And then the second antinode is also located at 22.5. What's the distance between this, the node and antinode? When you subtract, what's the difference?
7.5.
7.5. So it's giving you the same value. If you look at the third node and antinode, the third node is 30. Third antinode, 37.5. The same distance. Festus, go ahead. I'm listening.
Sir, please, I want to ask a question.
Go ahead.
I compared the equation to the general equation,
Mm-hmm.
and I found the wavelength.
Mm-hmm.
As I find the wavelength, yesterday they gave us a formula from a node to antinode. He said that's 1/4 of the wavelength.
Yes.
And I used that formula and I got a 7.5. Is that accepted?
So yes, you can determine position of node and antinode using angles or wavelengths. So the same thing. It's the same thing. Are you okay?
Yes, sir.
Don't forget what we have here. Pi x over 15 is equal to 2 pi over lambda k. All right. So if you know wavelength, you can find x. If you know x, you can find wavelength. So okay, they can be interchanged and the value is the same. That is how come you got the same value. Are you okay?
Yes, sir.
Please, is there any other question? So it's not difficult. You just would have to understand and then apply. Please, I'll give you an assignment after this on this same thing. Spend time and do it for me. Okay, once you apply this in solving problems, the better you become. Another question to the house. Two waves traveling in opposite directions. Two waves traveling in opposite directions produce a standing wave. Produce a standing wave. Y1 is equal to 4 sine. Y1 is equal to 4 sine so the first progressive wave, Y1 is equal to 4.00 centimeter sine sine 3.0 x minus 2.0 t, and Y2 is 4.00 centimeter sine 3.0 x plus 2.0 t. Hello, give me a minute. I'm coming in. So back from commercial break. All right, so these are the two waves. Here, instead of omega t, they are bringing kx first. So don't be confused. Now the question. The first question, find the amplitude. Find the amplitude of the simple harmonic motion of the particle. Find the amplitude of the simple harmonic motion of the particle of the medium located at x is equal to 2.3 centimeter. Find the amplitude of the simple harmonic motion of the particle of the medium located at x is equal to 2.3 centimeter. So you are to determine the amplitude or the displacement of the particle when x is equal to 2.3 centimeter. That is A. Then B. Find the positions of nodes and antinodes. Find the positions of nodes and antinodes.
Mr. Dia,
Hello.
please can you send the question to the platform?
Why? Charlotte, why? You are not getting it.
Yes, please.
So the way it is, then it means I have to type. Let me go over, okay? Let me go over if you mix out on some areas. Two waves traveling in opposite directions produce a standing wave. The individual waves are y1, which is equal to, the individual waves are y1 is equal to 4.0 centimeters sine 3.0x minus 2.0t. Okay. And y2, 4.00 centimeter. Yeah, please don't be confused with 4.00 centimeter. All that they are saying is that this is 4 and the amplitude is in centimeter. So it's the same as just writing. This is just the same as writing 4 y1. Y2 is also equal to 4 sine. Okay, Charlotte, are you okay?
Yes, please.
Then A. The first question is that find the amplitude of the simple harmonic motion of the particle of the medium located at x is equal to 2.3. So you are determining the displacement, okay, when x is equal to 2.3. Don't forget, amplitude is the maximum displacement. Here, technically, they should have said displacement because the amplitude does not occur at 2.3. So you are determining the displacement when x is equal to 2.3. And B, find the position of the nodes and antinodes. And then the C question is that what is the amplitude? C, what is the amplitude of the simple harmonic motion of a particle located at an antinode? What is the amplitude of the simple harmonic motion of a particle located at an antinode? So we are looking at the amplitude when an antinode is formed. That's the C question. We are calculating the amplitude where an antinode is formed. Class, are you okay?
Please, can you read just the A again? I like
A, the question A is that Charlotte Hardy. Find the amplitude of the simple harmonic motion of the particle of the medium located at x is equal to 2.3. Find the amplitude, okay, of the simple harmonic motion of a particle of the medium located at x is equal to 2.3 centimeter. So just give it a try whilst I update attendance. So I'm expanding what is within the bracket after factorizing out 4. So if the expansion of this is this, okay, then plus the expansion of this one, which is also this. Now, when you compare, you realize that sine 3x cos 2x, okay, sine 3x cos 2x, sine 3x cos 2x. So you can add this and this. They are alike. These are also alike, but this is minus, this is plus. So this will eliminate this. So we have 2 sine 3x cos 2t. Therefore, the stationary wave equation is equal to 8 sine 3x cos 2t. How many of you got this as the equation of the stationary wave? Let me hear voices. Don't raise up your hand. Let me hear your voice if you got this. Mention your name. Hey, nobody got this.
Ama.
Amma got this. Who else? Festus, Calvin, Doku, and the rest of you. Equia,
Yes, please.
Lizzie got it.
Yes, please.
Who else? Stephanie, did you get it? Or Stephanie is gone. Nah. Hey, I'm not critical. Natalie, Della, Nathania,
got it.
mention your name. Who are you?
Della.
Okay. Samuela, Odniel, Tucci, Na, Festus, Asumani. But this is simple to obtain. So, all right. Then the question is that determine the amplitude A. The A question. Determine the amplitude, okay, of the simple harmonic motion of the particle for of the medium located at x is equal to 2.3. So when x is equal to 2.3, what will be the amplitude or displacement? Here is about amplitude. So you need to tackle the amplitude function of the stationary wave, ASW, which is equal to 8 sine 3x. That's the amplitude function. So if the question is asking you to determine an amplitude at when x is equal to this, the amplitude function is what you need to, okay, tackle. So if x is equal to 2.3, you have 8 sine 3 times 2.3. So 8 sine, this is 6.9. Now, how to punch this is very, very important. You see, in simple harmonic motion, in every simple harmonic motion, theta, any sine, cos, tan, fine. In SHM, it is in sine and cos. 6.9. 6.9. These values before, these values before sine and cosine are angles. Numbers before sine and cosine in simple harmonic motion are angles. And the SI unit of angular displacement is the radian. So when you are punching this, 8 times sine 6.9 or cos 6.9, you need to set your calculator angular measurement in radians. How do you do that? Press on shift mode. My calculator is not even shifting. Shift mode. Oh, my calculator is misbehaving. Oh, this is your doing. Shift mode, then you press on 4. Hey, oh, it's rather unfortunate. So shift mode, then you press on 4, the normal 4. It will change your calculator angular measurement from degree to radian. So when you do that, you realize that you have capital R written on top. So it was shifted from degree D to R. Okay, those of you with that Texas Instrument and other calculator, you also see RAD. If it changes to R or RAD, then it means that your calculator's angular measurement is in radian. And that is what you use to punch something like this. Okay, so you first punch sine 6.9, and that is giving us 0.5784. Please, are you getting the same value?
No, please.
Oh, sine 6.9.
8 sine 6.9.
No, punch sine 6.9 first. When you finish, you multiply by 8. So this is it. Then this times 8. And the value is 4.628 centimeter. Please, is that what you got?
Yes, please.
Good. There is also a plan B. The plan B is that I can also change angular measurement from radian to degree. So I know that 2 pi is equal to 6.28 radian. Just substitute pi and multiply by 2. It's equal to this. So if 2 pi, which is 360 degrees, is to 6.28 radian, then if I have 6.9 radian, will it be more or less? With this, I'm only trying to convert angle in radian to degree. So if 360 is to 6.28 radian, what will be 6.9? Will it be more or less? Will it be more or less? Hey, you can't answer. If 6.2,
Yeah.
it will be more. If more, let's divide. So 6.9 divided by 6.28 times 360 would give you the angle in degree. Please calculate it and give me the angle in degree. Just give it to me. 395 degree approximately, correct?
No, then it will be 6.
Okay, 396. So
Yeah.
the plan B is that, okay, this time around, you see, I've converted my angle from radian to degree. So 6.9 radian is equal to 396 degrees. So instead of calculating in radian, I can calculate in degree. So 8 times sine 396 degrees. Now, if I want to calculate in degree, then I must change my calculator's angular measurement back to degree. So from radian to degree. So the same method, shift mode, then you see degree is DEJ is at 3. So you press on 3. It will reset your calculator's angular measurement back to degree. Okay, so you can switch to radian, you can switch to degree. So I want to calculate this in degree. So sine 396. This is equal to 0.5877 times 8. And the answer is approximately 4.7. It's 4.7. What did we make for when we calculated in radian? What did we make when it was in radian? 6.9.
4.628.
Okay. You see, there's a little drop. The little drop is that, you see, when Charlotte, when you were calculating, we express this to the nearest degree. So you round it. That is why there's that drop, little drop. If we had used what you had as 395 point blah 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 blah, we would have had the same value as we had earlier. So this is how to do that. All right.
Yes, please.
So when x is equal to 2.3, the displacement or the amplitude will be 4 points. Let me see what the book has. Okay, the book has approximately 4.6. Approximately 4.6. All right, so the next question. The next question is demanding calculate positions of nodes and antinodes. I'll do this. Let's do this so with some speed. Positions of nodes and antinodes. So our equation is y is equal to 8 sine 3x cos 2t. So it means that this is closed boundary or barrier, because the amplitude function is expressed in sine. It's a closed barrier. So for antinode, a sine 3x must be equal to plus or minus 1. If you remember the formula straight away, you can use it. Okay. Therefore, 3x, sine 3x or 3x. 3x will be equal to possible angles 90, 90, what again? From 90, what's the next angle? 90, 180,
27.
pardon? 270. So 3 pi on 2. So n will be equal to 2n minus 1 all on 2 pi. Okay. Are we okay? So 3x is equal to 2n minus 1 all on 2 pi. It means that x will be equal to 2n minus 1 all on 6 pi when we divide through by. So if n is equal to 1, x will be equal to 1/6 pi. X will be equal to, if n is 2, we'll have 3, and if n is 2, we'll have 3 pi, 3 pi on 6, which is also equal to pi on 2. So this becomes different positions of antinodes. Okay, the rest is by indicating the first antinode, second, n is equal to 2, 3, blah, 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 blah. Okay, please take note of this. If pi occurs in sine, cos, or tan, pi becomes an angle. So if I have this as sine pi on 6, cos pi on 6, tan pi on 6, whatever is here is an angle in radian. Okay, this is equal to an angle of 30. But if pi occurs like this, pi value is 22/7. So this is also the same as 3.142 divided by 6. Okay, so note when pi is an angle and pi is not an angle. If it's in front of sine, cos, tan, then it's an angle. It can even be represented as, maybe I have 2 pi sine pi on 6. This is an angle. Pi here is not an angle, it's a number. Lizzie and Co, are you with me? Akuya, Charlotte, Amma.
Yes, please.
Because if you are not careful, whenever you see pi, you may think it's 180, but it becomes an angle when it's in front of sine, cos, or tan. If it's a coefficient, it's not an angle. So this is the same as 2 pi times sine pi on 6. Over here, pi is an angle. Over here, pi is just a number, 3.24. This is not 360. This is approximately 6.28. But over here is an angle, which is equivalent to 30 degrees. That's the difference. Any question? Any question? All right. So once, Amma.
Mr. Happy, so the amplitude at the antinode will be 0.523 meter, right?
We are yet to answer that. Okay. So I'll leave the node, position of node to you. You can, once we have done antinode, you can easily work on node. The whole thing is that for node, the amplitude must be equal to 0. Blah 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 blah. Then so let's look at the C question, which is the amplitude. What is the amplitude of the simple harmonic motion of a particle located at the antinode? So the amplitude of a particle located at the antinode, here we expect 8 sine 3x, which is the amplitude of the stationary wave. Okay, we can obtain an amplitude of plus or minus 0 when sine 3x is equal to plus or minus 1. Right? Therefore, 3x will be equal to 90. 90 will be 1. Okay. So if we even use 90, we are there. We are not interested in possible antinodes, but this time we are looking for x value, which will give us an amplitude of 8, plus or minus 8. So pi on 6. So if x is equal to pi on 6, we have located an antinode. Okay. If x is equal to pi on 6, we are locating an antinode which represents an amplitude of 8 plus or minus 8 centimeters. So this position would give us an antinode, but there can be several positions which would. So these positions, x positions, will give us an amplitude of 8 plus or minus 8 centimeters. Am I okay?
No.
So all that I'm saying is that we'll locate an amplitude. This is the amplitude. But don't forget, the different x positions will give us antinodes, which represent the amplitude. So to get an amplitude of 8 centimeter, okay, a particle vibrating at x is equal to pi over 6 will give us an amplitude. There can be several. Okay, we can derive several x positions where we'll have an amplitude of 8. So the amplitude of the stationary wave is actually 8 centimeters, but we are looking at particle vibrations which would relate to amplitude. That's all that I'm saying.
Mr. Yeah.
Amma,
Please, are you answering any question or something?
I'm talking of C. What is the
And
amplitude, okay, of the simple harmonic motion of a particle located at an antinode? The amplitude is plus or minus 8, but I'm trying to locate x particle locations which will also connect to this amplitude of plus or minus 8. That is all that I'm saying. Are you
yes.
So as I said, I'll send you questions on this today, sample questions to try. But let's look at application of stationary wave. How is the concept of stationary waves applied in everyday life? So applications. Herbert, are you there, Festus? Festus. Applications of stationary wave. The concept of stationary wave is applied severally. One typical example is in string instruments. String instruments. So all musical instruments that uses strings, guitar, violin, harp. Name them. Those of you in regimental, help me. I've mentioned 3. Guitar, violin, then harp. Help me mention more string instruments. Charlotte, you are in regimental. Help me with another.
No, please. I'm in cadet. Not
when it came to you are switching to cadet. Lizzie,
Oh,
Equia Boatima, you are in regimental. Give me another one. Equia Boatima is gone. Hey, Equia Boatima, you are here. Elvina, you are also in regimental. Give me an example of string instrument.
Mr. Do I have?
Oh, but I've said it too. Cello. Nana.
Yeah, you said all of them.
Okay. Somebody is also, Nana is talking about cello. So guitar, violin, harp, cello. So all these instruments operate on the principle of stationary wave. In fact, what you actually dance with, that pom 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 guitar sound, is due to resonance in sound. Okay, so as the guitarist play, pim, 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 then the other finger, they are doing something which I'll tell you. You are applying stationary wave. Another application of stationary wave is on all pipe or wind instruments. Pipe or wind instrument. Example, trumpets. Charlotte, regimental, give me 2.
Oh, trombone.
Hey, trombone, I can spell. Spell for me. T.
Unless I ask Google.
Yes, anybody to help.
O
T.
M
I'm listening.
TROMBONE.
ONB. B.
ON.
ONE. Trombone. Let's confirm. And so check, recheck.
ROM.
And so you can look for it and then, okay, this is not an instrument I'm familiar with. So trumpet, trombone, wind or pipe instrument. Pipe organ. Or even organ. More wind instruments. Flute, good. Flute. Amma, give us one. You play trumpet. Oh. Euphonium. Hey, Nana and your instrument. Euphonium, so why? Okay. Euphonium. Then you are forgetting the harmonica. This is for 5. Nana is euphonium. And then the harmonica, aka mouth organ. Okay. So these are all instruments that work on the principle of stationary wave. So when trumpet is being played, what are they doing? They are blowing air. And then they control the valve. Okay. All that happens in there is resonance in pipe. We'll look at it. Then guitar, those things, they are applying stationary wave. They are creating waves. They are creating wave on a string, and when progressive wave, and when the wave hits the other boundary, it will reflect. So if you play guitar, when it is plucked or the string is disturbed, you see a wiggling of the guitar string at the fixed point between, okay, it wiggles up and down. It remains stationary. But as they play, they use the other hand to create an artificial barrier. Okay, so bono, then the hand will be tapping the guitar string. He's doing something which is in line with what we are coming to study. Is that okay? So let's look at vibration in strings. And this is purely reserved to string instruments. Vibration in strings. I have this length of the string, L. You know, string instruments are closed boundaries. There are boundaries at both ends. So this is boundary or barrier 1. and then boundary 2. So if you watch so carefully in guitar, you see the ends about 4 or 5 strings with different width or sizes fixed at one end. Then the other end is connected to a metallic something that can be tuned. So if you play guitar in your church, you may be familiar with this. So this indicates the barrier at both ends. Okay, please, I'm sure you've seen this before. Those of you who are familiar with musical instruments, like Ekwia Doma and Adwa Utubia. So I have a string of length L. Now to create stationary wave, you need to plug one end or disturb the string. So ping, that is plugging, but they do that to create beats or music. They plug it continuously. Ping, 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 ping. One string. Now, stationary waves are formed with a particular wavelength and frequency. Stationary waves are formed with a particular wavelength and frequency. What I mean to say here is that for wavelength, for stationary wave, you need a particular wavelength and frequency to form it. But for progressive wave, any wavelength and frequency can form it. But for stationary wave, you need a special a particular frequency and wavelength to form it. So these are special. So when the string vibrates, several stationary waves, which is also known as notes, N-O-T-E-S, are formed per a disturbance. So on blocking the string, several stationary waves or notes as a notebook. Okay, several stationary waves or notes are formed. Okay, the evidence of this is that, you see, if you have a string, not necessarily only guitar, but if you have a string tied to 2 ends and you disturb it, you hear sound, that continuous sound. If you have guitar of any kind, just plug it once and listen to the sound that will be produced. Several continuous sounds will be produced. So upon one plug, you see, the sound you hear, it's not just one stop sound, then it ends. One plug will produce continuous sound. Then this is an indication that upon disturbance of the string, several stationary waves or notes are produced, and the numerous stationary waves or sound is what gives that continued sound. Please, are you with me? Hello?
Mr. I have a guitar.
Good. I want you to pick it, then just plug it once and listen to the kind of sound that will be produced.
Okay.
The sound is not just one stop sound. No. Upon one plug, that continuity. Is it close to you?
Yeah.
I'm listening.
Okay. I don't know if you guys will hear.
You do it and then give us feedback.
Can you hear?
Come again. It's not reaching us. But did you hear what I said?
Yeah, I did.
So one disturbance produces that continuous sound. The continuity of the sound is an indication that the stationary waves produced are several. That is how come the sound is not just dying upon one. Okay, it's not like, but when it is the same, that continuity. And what you hear is as a result of the several stationary waves that can be produced upon one vibration or disturbance of the string. Okay. So stationary waves are formed with a particular wavelength and frequency, meaning that there are special wavelength and frequency which forms stationary waves. Then two, on plucking the string, several stationary waves or notes are produced. Okay. Now, if I have a string of length L, the first possible notes or stationary wave, the notes are also the stationary waves that can be produced as this. The fundamental stationary wave or notes that can be produced is this. The trick in generating the notes can be done using progressive wave. Don't forget, stationary waves are just two progressive waves moving in opposite direction. So if I have a progressive wave of this nature, once I have boundary at both ends, it means nodes will be formed at both ends. Okay, so the first stationary wave that will be produced will start on a node. Charlotte, I'm listening. No, Charlotte, just one plug. Just strike it once and stop. Or just one strike, but you heard that continuous sound. Is that okay? So the first possible stationary wave that will be formed will start from a node and end with another node because there's a barrier here. So if I have a string of length L, the first possible stationary wave formed will look like this. It hits the barrier and reflects, creating the stationary wave or the notes. So this will be the first possible stationary wave or note. The first possible stationary wave or note. Now, this first possible stationary wave is part of that continuous sound that was heard. So we call this the first note or tone, basic tone. Now, if this is the basic tone or the first possible stationary wave, I earlier said that stationary waves are formed with a particular wavelength and frequency. So what is that particular wavelength and frequency which will form this basic or basic tone or first possible stationary wave? How I can determine the wavelength and frequency is that this length, L length of string, is equal to a wavelength which is equal to half lambda from node to node. So the wavelength is equal to half lambda, implying that the wavelength which will form this will be equal to 2L on 1 or 2L. I said that this stationary waves are formed with a particular wavelength and frequency. So this is that particular wavelength which will form this. And this is known as the fundamental wavelength. Fundamental wavelength. So the fundamental wavelength is equal to 2 times the length of the string. Meaning, if the length of the string is equal to 1 meter, then the wavelength would also be 2 meters. If the length of the string is 3 meters, the wavelength will be 6. That is basically what it means. So we have identified that particular wavelength which will form this. What about that particular frequency? When the string is disturbed, what you hear is a sound. So, okay, what you hear is as a result of velocity of the speed of sound in air. So, speed of sound is equal to frequency times wavelength. So, to determine the frequency which will form this, F must be equal to V over lambda 1. V over lambda 1 is equal to 2L. Okay, where F is termed as that particular frequency which will form this. V is the velocity of sound in air. L is the length of the string. F is termed as the fundamental frequency. Fundamental frequency or the first harmonic. First harmonic. So F1 is the fundamental frequency or the first harmonic. So all that I said, all we are doing is that stationary waves are formed with a particular wavelength and frequency class. Class. In fact, hello. Yes, I'm listening.
You were calling us, so I was like, yes, yeah.
And today we should have gone through assessment. Or the saying the appraiser of the teacher. In fact, I was supposed to have done this last week. Unfortunately, I forgot. And this week as well, I've forgotten. It's usually a scary thinking that previously I was ending my classes on Friday. So I thought I still have another day to finish this. Hey, Asemo. Class, I will send it to you. I beg you, I'll send it personally to each one of you. Find time to do it for me. I'm sure other teachers have done it. Correct?
Yes, sir.
And so I'll send it personally, individually to you. I beg you, find time and do it for me. I think the teaching seems to be sweeter than my own appraisal. Okay, so I'll send it to you so you make time to do it for me. Do not skip. So on this note, this is where we draw the curtains on today's meeting. We'll continue this next week. In fact, this is a very exciting area to understand. So we are going to continue with it next week. But then, please, I'll give you work sets to try. Do it and then bring it to me to go through it for you on stationary way. Then I'll also forward my evaluation. I beg you, spend time, do it for me. So until next week, may the good Lord be with you. Take care of yourselves and then be careful. That those of you NDC supporters celebrate, okay, not so much. Do not tease them and us. Okay. Until next week. In fact, bye-bye.
Bye. It is visible. It is visible.
Bye.